Hello everyone. I'll be starting a series about geometry. We'll be covering first an introduction, then we'll go through triangles, quadrilaterals, polygons, circles, 3D shapes, and composite shapes. So today I'll be going over the introduction. So we'll cover points and lines, parallel and perpendicular, angle equivalences, building polygons, congruence and similarity, and general nomenclature in geometry. Alright, so first, points and lines. Let's just start with a point. It's going to be a single spot, and we can label it with a letter or anything else we want to label it with. And its only information is just a point in space. And it can have another point, so this is point A, this is point B, and a line would just be a line that goes through both of these points and extends forever. So a line has constant direction, a line is straight. Now you may think, oh, a line A to B would just be A to B, but that's what we call a segment. So a segment, this is segment CD, is just a line that only covers the part between 2 points. So if we imagined a line CD would extend in both directions, but a line segment only goes from the point to point. Now beyond a line segment, there's also a ray. So a ray will start at a point and extend in the direction of another point and then keep on going in that direction forever. So line segment, and ray. When another line crosses over, at that point we will get an intersection, and we can label that intersection. And so whenever these two lines, whenever there's a point of intersection, we call that a vertex. And we could, for example, the line AH and the line AB, they're actually the same exact line, but they're just called something different. So those lines technically intersect along their entire range. So at every point along this line, AH and AB will be intersecting. But along the lines AB and HJ, they only intersect at this one point. Points don't need to always have a special line coming from them. You can just arbitrarily call a point anywhere on a line or anywhere in space. And we can use this line to maybe denote a specific segment. So maybe the segment HG or GB. And we can do certain math, so we know the line segment AB will be longer than AH or AG, but we know that AG plus GB will equal AB. So points, lines, line segments, and rays, and intersections, and then vertices. And then here's how we would denote. So the line AB is what this would look like, the ray EF, and the line segment CD. Now parallel and perpendicular. So a parallel line is essentially, if we had this line and we just copied it, took the exact same line, and then just moved it down a little bit, we will get a parallel line that is in the exact same direction, but just offset a little bit. And because it's in the same direction, the offset will be maintained for every single point as far as you go in any direction. So these lines will actually never cross because they're parallel. So parallel lines are essentially just the exact same line with a bit of an offset. And technically, AB is parallel with itself, but it's also equal to itself. But AB is not equal to CD, but they are parallel. And then perpendicular is when you have a line and another line that is not the opposite direction, but kind of halfway rotated. And we call that a right angle. And so this is essentially where here to here is 180 degrees, halfway is 90 degrees. So perpendicular will always be a right angle or a 90-degree angle. So this is parallel, these are perpendicular. And the notation is, if we wanted the line EF and GH are perpendicular with this symbol. The line AB and CD are parallel. And we could also say that EF and GH are not parallel with this symbol. Not parallel doesn't necessarily mean perpendicular, because any angle between 0 and 90 would be not parallel and not perpendicular. Next, let's go through some angle equivalences. So whenever you have intersecting lines, so AD and CB intersect at this point E, we can use what we know about rotations to say some things about these angles. So we know a full circle is 360 degrees. So all in all of these angles should add up to 360 degrees. And we also know a line would cut that exactly in half. So on each side of this line, there's going to be 180 degrees. And same thing with this line, 180 degrees. But we also know that with this 180 degrees, with this intersection, we'll cut that in half. So this plus this will add up to be equal to 180. And whenever that's the case, we call those supplementary angles because they supplement to form a line. But these are supplementary, and these are also supplementary along AD. But since these two are supplementary to the same portion, we know that these sides, these angles, are actually equal because they both have the same part cut out of them. So this angle here and this angle here are equal, and the same is true for this angle and this angle. And whenever we have these, we call these opposite angles vertical angles. And it doesn't need to be up and down or side to side. It's just kind of opposite sides of an intersection are called vertical angles. And so we would call this AEC angle is equal to BED, and AEB is equal to CED. Another angle equivalence is when we have two parallel lines, so this top line and this bottom line are parallel, which means they're essentially the same line. And so if you have another line that goes through both of these, we'll call this the transversal line. Because this has the constant direction and these have the same direction, all of these angles are essentially the same, because this is just the same line moved down here. The angles won't change. So if we labeled all of these angles, we could call all of the angles that are in essentially the same spot corresponding. So 1 and 5, 2 and 6, 3 and 7, and 4 and 8 are all corresponding angles, and corresponding angles will be equal. And then another thing is same side interior and same side exterior. So same side refers to on the same side of this line of the transversal. So 1, 3, 5, and 7 are on the same side. 2, 4, 6, and 8 are on the same side. So same side interior will be on the inside of the parallel line. So 3 and 5 are interior. 4 and 6 are interior. Same side exterior will be 1 and 7 and 2 and 8. And same side interior and same side exterior will all be supplementary. So 3 and 5 will add up to be 180 degrees because we know 1 is supplementary with 3, so 5 will also be supplementary with 3. There's also alternate interior and alternate exterior. So alternate will mean on other sides of this transversal. So alternate interior will mean 3 and 6, also 4 and 5. And alternate interior will be equal angles, so 3 is equal to 6 and 4 is equal to 5. Alternate exterior will be 1 and 8 and 2 and 7. So these will also be equal. So same side are going to be supplementary. Alternate side will be equal, and corresponding will be equal. Interior and exterior just refer to if you're within the parallel lines or outside of them. So these are the main ways we can conclude that angles are equivalent in geometry. And we'll be using these to make some proofs about what angles are in triangles and other polygons. Speaking of polygons, we first have to describe what it is. So a polygon is a set of points connected by a set of line segments where it encloses a shape. Another way you could define it is a set of points that each only have two and exactly two lines coming out of them, or lines intersecting at that point. So we can't have something like this, because then this point would have three lines that all intersect there, or there's three directions coming out of this one line. So it all needs to be one line goes in and one line goes out of a point. And so it will essentially form a closed loop, and that's what a polygon will generally be, and a closed loop of points and straight lines. And so this has three vertices and three sides. So this is what we'll call a triangle, because it has three angles. And then this one, see, it's also a polygon. It has four vertices and four sides. Generally, any polygon, the number of sides will be equal to the number of vertices. And this would be called a quadrilateral, because four sides. And then this, there are five vertices and five sides, so we'll call this a pentagon. And this is actually special, because if you notice, it looks like it's kind of been crushed in a little bit. And so something like this is what we'll call concave, and something like these is what we'll call convex. So concave has kind of a bit of an indent inside of it, but it's still a polygon, and it would still be a pentagon in this case. And we can keep on going, so pentagon, hexagon, heptagon, then octagon. So this would be an octagon. It has 8 vertices, 8 sides. You may see, look at these and see, that doesn't really look like polygons, not what I'm used to. But that's just because these are general polygons that have kind of random edges, random sides, random angles. But what you're used to seeing are regular polygons. So those look a lot more uniform, and this is what they'll look like. So this is a regular triangle, a regular quadrilateral, regular pentagon. This is a regular hexagon, and actually a regular quadrilateral has a special name. It's called a square. And I'll talk about more about polygons in my polygon-specific video. But first, let's talk about congruence and similarity. So let's say we have a triangle, and we'll denote each side has a different length by using these hash marks. So this is different than this, and this is different than this. But if we have another triangle, and we see, oh, this side is equal to this side, it has the same hash marks, kind of label it the same thing. This side is equal to this side is equal to this. So a triangle with all equal sides will always be congruent to another triangle with all equal sides, or with each side equal to a corresponding side. And so, let's say we knew that this side was 3, this side was 5, and this side was 8, or whatever. And we knew that this was a corresponding triangle. We know that this side is also 8. So we know that these triangles are exactly equal. But just because they're not the same, they're not denoted the same, like this could be ABC and this could be DEF, they're not the same triangle, but they're just congruent triangles. So they would have equal perimeter, area, and everything else. And we could imagine even rotating this, it will still be congruent. But what if you have a triangle that looks the same, it's just shrunk down or shrunk up a little bit? So let's say these triangles are similar, meaning, let's say this was the side of 1, 2, and 3. Then this side is 1/2, 2, and 3/2. Meaning every side of this one is twice as big as here. So that means these triangles are similar. Their sides are proportional. Their angles are always going to be equal. And so if we knew these two sides, if we knew this entire side and we knew the kind of the rate of proportionality, or the proportional constant, we could determine each one of these sides. Or if we knew all of these sides, or any of these sides and these sides, we could determine the rate of proportionality from that. And it's not just triangles, any polygon can be similar. In fact, any shape can be similar. Now, just some general nomenclature. So with polygons, there's convex versus concave, which remember, convex will be normal looking. Your kind of every point turns more in the same direction until you get back to where you started. By concave, some points will kind of indent more and then come back out. It might look spiky or dented. And then regular, meaning it's uniform. So something that's regular will be both equilateral and equiangular. And equilateral means all sides are the same length, and equiangular means all angles have the same degree. And parallelogram means all opposite sides of a polygon are parallel. So actually a triangle can't be a parallelogram because it has an odd number of sides, so it doesn't have an opposite side, right? But a quadrilateral can be, a pentagon can't. So anything with even sides can be a parallelogram, but not all of them are parallelograms. Also, the distinction between a point and a vertex is always the point of intersection of two lines, but a point can just be any general thing. And then the side of a polygon, we can add up all the side lengths and we'll get the perimeter. So instead of using the line of a polygon, we'll call it the side or the edge. Now some dimension nomenclature. So length, width, and height. Those are useful when doing anything with volume. And with circles, we'll use radius, diameter, and circumference. But we'll also use perimeter. There's area and volume. Then surface area is the area of the faces of a 3D shape. In polygons, the apothem is the length between the center of the polygon, and it's generally in a regular polygon, to the edge of a face, and it's always a right angle direction or a perpendicular direction. And then the slant height, this is in a cone. We're kind of considering the diagonal length or the diagonal height of something. There's also other general nomenclatures. So bisection, we'll use that a lot. That's whenever you kind of cut something in half, and usually it will be with a line, the midpoint is exactly in the middle of the line segment. And actually a midpoint always bisects a line segment. And then there's complementary and supplementary. So supplementary, we already discussed, means two angles that add up to 180 degrees. Complementary is two angles that add up to 90 degrees. These are kind of about higher dimensions. So a line is one-dimensional, a plane is two-dimensional, and a space is three-dimensional. But objects in those dimensions is an edge, a face, or a solid. Another word for a solid that's kind of like a polygon is a polyhedron. So that's the word for a polygon in three-dimensional space. And then any dimensional space above 3 dimensions is called a hyperspace, so something 4-dimensional or 5-dimensional. And then also generally a line versus a curve. A line is always straight, it never changes direction. And a curve is always changing direction. So something like an arc or a parabola, these are curves, so they're essentially anything like this, these are all curves. A line will always be straight, and a line will always be the shortest distance between 2 points, but a curve will be some other connection between those 2 points. And that's the first introduction of geometry. Next video I will be going over triangle geometry. So look forward to that, and let me know if you have any questions, and thank you for watching.